The Rust Programming Language, Chapter 5, Section 2, and adding useful functionality with derived traits. It'd be nice to be able to print an instance of our struct rectangle while we're debugging our program and see the values for all its fields. Listing 5.1 tries using the println macro, as we have used in previous chapters. This won't work, however. There it is. Attempting to print a rectangle instance. When we run this code, we get an error with this core message. Rectangle doesn't implement standard format display. The println macro can do many kinds of formatting, and by default, the curly brackets tell println to use formatting known as display, output intended for direct end-user consumption. The primitive types we've seen so far implement display by default because there's only one way you'd want to show a 1 or any other primitive type to a user. But with structs, the way println should format the output is less clear because there are more display possibilities. Do you want commas or not? Do you want to print the curly brackets? Should all the fields be shown? Due to this ambiguity, Rust doesn't try to guess what we want, and structs don't have a provided implementation of display. If we continue reading the errors, we'll find this helpful note. The trait, a standard format display, is not implemented for rectangle. In format strings, you may be able to use this or this for pretty print instead. Let's try it. The println macro call will now look like, it's the same except for inside of the, someone in the comments please tell me what do we call the space holder, this? What is that called? Okay, so in the placeholder there is this, and so putting this specifier inside the curly brackets tells println we want to use an output format called debug. So the specifier ::. The debug trait enables us to print our struct in a way that is useful for developers so we can see its value while we're debugging our code. Run the code with this change. Drat! We still get an error. Rectangle doesn't implement standard format debug. But again, the compiler gives us a helpful note. So the trait standard format debug is not implemented for rectangle. Note, add #derive debug or manually implement standard format debug. Ooh. Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the annotation derive debug just before the struct definition. So here it is, derive debug, right there above struct rectangle, outside of the main function. Now, when we run the program, we won't get any errors, and we will see the following output. Well, okay, moving on. This output. Nice! It's not the prettiest output, but it shows the values of all the fields for this instance. Well, let's go back and do that then. Why not? So what do I take out? The hash. Yes. Because I didn't actually do this before. I want to see what it looks like. Yeah. So of course I put in my new line here right before rect1 and then 2 new lines. I don't know if there's a better way to do this, but this works. Because I just like a little bit of space, you know? And I'm curious actually if I can make a tab. Like, I don't know, \t. Oh, it's yellow. Oh, now this is happening. Let's see. Look at that. Okay. So it's not the prettiest, but it shows the values of the fields. So it's helpful for debugging. When we have larger structs, it's useful to have output that is a bit easier to read. In those cases, we use :hash ? Instead of just : in the print line string. When we use this, what do they call it? Something with an S, specifier, okay. When we use the pretty print specifier style in the example, the output will look like this. I changed two things, so let's do this. F to a ? And there it is. Insert hashtag right quit. No, right. Not right quit. That doesn't look as good. Let me take the tab out. So it looks like, so I was thinking, if \n gives us a new line, maybe we get \t for tab, and it is the case. Doesn't look so great here though. Yeah. What did it look like before? It only tabbed to that. So I guess you'd have to tab each new line, right? Yeah, of course I am. Oops, that's not what I meant to do. Oh yeah, okay, I guess it is. So we have, let me go ahead and add myself a new line to look at in each place that I tell it new line. So inserting that, yes, and then there's another one, so insert that. And then we tab this, and why isn't it tabbing the whole thing? See, because I don't have any more new lines to tell it. I mean, I could just guess, but I couldn't make an educated guess. Well, I didn't see that coming. I thought it didn't care about white space. How far back do I go? If I just keep undoing, it'll give me a yes. Okay. So now we're back to this. Fine. Rust has provided a number of traits for us to use with the derive annotation that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We will cover how to implement these traits with custom behavior as well as how to create your own traits in Chapter 10. Our area function is very specific. It only computes the area of rectangles. It would be, it only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work with any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method defined in our rectangle type.